When working with parent functions, it's important that you're able to identify some defining characteristics. We'll start with the parent function for quadratics. The parent function for a quadratic is f of x is equal to x squared. All quadratics have a vertex. For the parent function, the vertex is located at the point 0, 0. It's at the origin. So a quadratic is a parabola. So the graph of the parent function is going to look something like this. The domain of a parent function is infinite. It spans from negative infinity to positive infinity. The range, however, is bounded because the vertex serves as the point at which the graph changes direction. So there won't be any part of the graph that is below the x-axis. Therefore, the range spans from 0 to positive infinity. A quadratic parent function is symmetric to the y-axis. That makes it an even function. The graph is increasing on the interval 0 to infinity and decreasing on the interval negative infinity to 0. This notation is referred to as end behavior. When we describe end behavior, we are identifying the direction that we are moving on the x-axis, and we are describing the behavior of the y values. When you describe the behavior of the y values, you're going to look at what the ends of your graph are doing. So if we start with x going to positive infinity, so as I move right along the x-axis, the graph of my function goes up. So y approaches positive infinity. As I move left on my x-axis, so towards negative infinity, my graph is going up. So it also approaches positive infinity. In the previous lesson, we talked about positive and negative functions. The graph of a parent quadratic is always positive because it always lies above the x-axis. It is never negative. The x-intercept of the parent function is the origin, 0, 0, and the y-intercept of the function is the origin, 0, 0. For cubic functions, the equation of the parent cubic function is f of x is equal to x cubed. A cubic function doesn't have a vertex. However, its x-intercept and y-intercept are the same as that of the quadratic parent function. It's at the origin. The domain of a cubic function is infinite, but unlike that of a quadratic function, the range is also infinite. What defines a cubic function is the shape of its graph. So it'll look something like this. And we say that it is symmetric to the origin, meaning it's an odd function. It is always increasing. So from negative infinity to positive infinity, when I move along this graph from negative infinity to positive infinity, the graph is always going up. So it's always increasing. It is never decreasing. Again, within behavior, as x goes to infinity, so on the right-hand side of my graph, as x goes to infinity, y goes to infinity. On the left-hand side of my graph, as x goes to negative infinity, y goes to negative infinity. This graph is positive on the interval 0 to infinity because that's the section of the graph that is above the x-axis here. This graph is negative here. So we say that it is negative on the interval negative infinity to 0. The next function is the square root function. The equation of the parent square root function is f of x is equal to the square root of x. Because we can't take the square root of a negative, the domain and the range of the square root function is bounded. The smallest value of the square root function to be defined is 0. And when x is 0, y is 0. So the x and y intercept for the square root function is the same as that of the quadratic and the cubic. The domain, however, is bounded. So the graph of a square root function will look something like this. The domain spans from 0 to infinity, and the range spans from 0 to infinity. The square root function is not symmetric to the y-axis or the origin. It is always increasing, but we don't say from negative infinity to positive infinity. We say that it's increasing on the interval 0 to infinity because we don't actually go to negative infinity. It is never decreasing. Now, on the right-hand side of our graph, so as x goes to infinity, my graph is going to continue to grow, so y goes to infinity. But on the left-hand side of my graph, I'm not going to approach negative infinity. I approach 0. And as x goes to 0, y goes to 0. This graph is always positive because it always falls above the x-axis. So we say it is positive on the interval 0 to infinity. Again, because we are never going to be negative because I'll always be above the x-axis. And I'm from 0 to infinity because I don't go past x equals 0. The next function is the reciprocal function. The parent reciprocal function is f of x equals 1 over x. Now, because we can't divide by 0, this creates some special boundary lines. We have a horizontal asymptote at y equals 0. That's the x-axis. We also have a vertical asymptote at x equals 0. That's the y-axis. So the graph of this function will never cross the x or the y-axis. So it doesn't have any x or y intercepts. When we look at the graph of the reciprocal function, if my x and y axes are asymptotes, then this graph is going to come from negative infinity and approach the y-axis. And then it's going to come from the y-axis and approach the x-axis. The domain is negative infinity to 0 and 0 to infinity, but I can't be 0. The range is negative infinity to 0 and 0 to infinity, but I can't be 0. I am symmetric to the origin. That makes this an odd function. And remember, to determine if you're symmetric to the origin, if you flip this graph upside down 180 degrees, would it give you the same graph back? And the answer is yes. The reciprocal function is never increasing. It is always decreasing when you read the graph from left to right. So as I move from left to right, I go down, and then I go down again. So I'm always decreasing. So I decrease on the intervals negative infinity to 0 and from 0 to infinity. As x goes to positive infinity on the right-hand side, y goes to 0. And as x goes to negative infinity on the left-hand side, y goes to 0. This graph is positive on the interval 0 to infinity. That's where the graph is above the x-axis. This graph is negative from negative infinity to 0. That's where the graph is below the x-axis. The next function is the absolute value function. The parent function for absolute value is f of x equals the absolute value of x. The absolute value function has a vertex very similar to that of a quadratic, and it's located at 0, 0. And just like that of a quadratic, a cubic, and the square root function, my x and y intercept occur at the origin. What defines the absolute value function from a quadratic is that instead of being a curve, absolute value functions has that very indicative V shape to them. The domain, just like a quadratic, is negative infinity to infinity. The range, just like a quadratic, is 0 to infinity, and I can be equal to 0. The symmetry, just like a quadratic, is symmetric to the y-axis, and that makes it an even function. I am increasing on the interval 0 to infinity and decreasing from negative infinity to 0. On the right-hand side, as x goes to infinity, y goes to infinity. On the left-hand side, as x goes to negative infinity, y goes to infinity. This graph is always positive. It's never negative. So we're positive on the interval negative infinity to infinity. The last parent function that we concern ourselves with on a regular basis is an exponential function. The parent function for an exponential function is f of x is equal to b to the power of x, where b is a real number greater than 0. Okay? B is a real number greater than 0, and not just greater than 0. In order to be an exponential function, you have to be greater than 1. In order to be an exponential growth function, you have to be greater than 1. So your y-intercept is always going to occur at the point 0, b, whatever that b value is. Okay, so your y-intercept is always going to occur. Your y-intercept is always going to occur at 0, 1, because anything raised to the 0 power is 1. And an exponential growth function is going to start small and then grow really fast. We have a horizontal asymptote at y equals 0, which is, again, the x-axis. The domain is infinite. An exponential function can be any value of x. The range, though, is bounded between 0 and infinity, and we can't be 0. You can never raise anything to a power and get 0 back out of it. An exponential growth function has no symmetry, and it is always increasing. It is never decreasing. On the right-hand side, as x goes to infinity, y goes to infinity. And on the left-hand side, as x goes to negative infinity, y goes to 0. This function is always above the x-axis, so it is always positive.